This is a video on the truncated cuboctahedron. This is one of the 13 Archimedean solids. In this video series, I'm showing how the Archimedean solids can be derived from the Platonic solids. In this schematic, we have the 5 Platonic solids across the top. In previous videos, we've looked at how we can derive Archimedean solids by truncation, rectification, expansion, and snubification. The last two Archimedean solids are found by truncation of existing Archimedean solids. This video is going to be looking at the truncated cuboctahedron. It's found by taking the cuboctahedron and truncating it to get this shape. This is the truncated cuboctahedron. Here's another rendering of the truncated cuboctahedron. It does have some slightly different names. This website calls it the rhombi truncated cuboctahedron. You'll notice that it is made up of squares, hexagons, and regular octagons. All faces of Archimedean solids must be regular. We do not have an applet that's going to allow us to truncate the cuboctahedron, but I will use this website to remind you how truncation works. Here we have the tetrahedron. Truncation cuts off the corners. Here we have the cube. Once again, truncation cuts off the corners. To do a proper truncation to get an Archimedean solid, you don't want to cut off the corners too small, and you don't want to cut off the corners too much. You want to cut off the corners in thirds so that the original edge is divided into 3 parts. So let's go ahead and take a look now at our figure. Okay, we're going to have to visualize the process. On the left-hand side, we have the cuboctahedron. And here is the data. The degree of each vertex is 4, meaning that there are 4 edges and 4 faces meeting at each vertex. Face type 1 is 4, which are these squares. Face type 2 is 3, which are the triangles. The cuboctahedron is made of 6 squares and 8 triangles. The total number of faces, therefore, is 14. The number of edges is 24, and the number of vertices is 12. Now, if we visualize truncation of this, let's take a look at this vertex right here in front. If we truncate this off, since it has a degree of 4, this vertex is going to turn into the square. Similarly, this vertex will be chopped off and turn into a square, and this vertex will be chopped off and turn it into a square. The triangular face here is going to become a hexagon, and this 4-sided face, the square, when the corners get cut off, it's going to become the 8-sided figure, the octagon. Pause the video now to analyze the truncated cuboctahedron. I hope you enjoy studying the many interesting properties of the Archimedean solids.